All right, welcome to the Exam 1 study guide. I have 28 questions here. They should mirror pretty closely what you will see on the exam. So if you can do this study guide and get the right answers, you are ready for the exam. The study guide does have multiple choice. The exam does not have multiple choice because I wanted to find the best examples I could of problems that looked like exam problems, and some of those happen to be multiple choice. The first question will be multiple choice on the exam. The rest will not be multiple choice on the exam. There will be, most important, there are 5 factoring questions on the exam. There are also 5 questions where they ask you to solve for x. There's, I want to go in order of importance. Then we have 3 radical problems. So you're going to multiply, add, or just simplify the radicals. When you're working with the radicals, make sure that after you find your answer, you can't simplify it any further, okay? So in any situation, even if you have like a distance formula question, make sure you simplify the radical as much as possible. So let me go down the list. 1 inequality question, 2 scientific notation questions, 1 evaluating, so they give you x and y, you plug it in, you get an answer. 1 adding or subtracting polynomials, 3 multiplying polynomials, 5 factoring, 1 division, 2 rationals where you reduce it to lowest terms or you multiply and reduce it to lowest terms, 3 radicals, 5 solving for x, including fractions that you have to solve for x, 1 distance, and 1 midpoint formula. So that's what's on the exam. I'm going to start the study guide now. Okay, so the first question is graph the numbers on x, graph the numbers x on the real number line. When x is greater than -10, so greater than is going to be like this because it does not include -10, and it should start at -10 and go for forever. So I'm going to say it's C. Write this number 0.066 in scientific notation. So I want to have one number in front of the decimal. So I'm going to move the decimal over 2 points, right? Right now it's here. I want it to be between the 6 and the 6. So it's now going to be 6.6. And then we have to multiply it by 10. And then we need to have an exponent of 2. Should this 2 be a -2 or a +2? Is this number getting bigger or smaller, right? If I take 6.6 and multiply it by 10 squared, I'll get, oh, I'm sorry, you couldn't see any of that. You'll get 660, right? Is that what I want? No, I want to get back to that, okay? So if your final answer is smaller than 6, then that should always be a negative, okay? We moved it 2 places, so that's where I got that 2. Now, they have it in decimal notation. They want you to write it in long form. So we have 6.79 times 10 to the 4th. You're also welcome to put this into your calculator. See what they tell you. Copy that down, right? Or you can say 10 to the 4th. Is that a big number or a small number? That's a big number. That's 10 times 10 times 10 times 10. I don't know what's going on, why I keep moving. Right? So I'm going to get bigger. So I'm not, if I move to the left, it makes my number smaller. If I move to the right, it makes it bigger. So 1, 2, 3, 4. 1, 2, 3, 4. 6, 7, 9, 0, 0. Good. 0.0, but don't confuse yourself. Just leave it like that, okay? Evaluate the expression using the giving values. So we have 3 times x times y plus 30 over x. Since it's alone, I'm not going to use parentheses, but you're welcome to. Now substitute 3. They said x is 5. 3 times 5. And that y is 7 times 7 plus 30 over 5. I'm just going to put 3 times 5 times 7 into my calculator. 105 plus 30 and divide it by 5. 105 plus 30 is going to be 135, right? Divided by 5. 135 divided by 5 is going to give me 27. Oh yeah, some of these are multiple choice, but I already warned you. Okay. In the given expression, calculated as indicated, it express the answer in a single polynomial in standard form. Standard form, remember, means that we're going to go y squared, and then we're going to go y to the first, and then we're going to go with our constant. Okay, so it has to be in descending order. This is not in standard form. Also, factored form is not standard form. So there are 2 reasons that this part is not in standard form. The y squared is behind the constant, and the 3 is being multiplied by 7 minus 8y squared. To be in standard form, you have to get rid of the multiplication that is implied by the parentheses and put it in order, okay? So 3 is going to be distributed to the 6y squared, the negative 3y, and the plus 4. 3 times 6 is, what now? I'm scared, 18? 18y squared. 3 times a negative 3 is a negative 9y. 3 times 4 is 12. So notice that I didn't change the y's at all, right? Because I'm just multiplying by 3, so that just means take that whole number in front of the y, or take the term in front of the y, and multiply it by the term outside the variable. Negative 3 times 7. Note that it's a negative 3, okay? Negative 3 times 7. Negative 21. And then negative 3 times negative 8. Positive 24. Y squared. I don't need this parentheses. You can add it or you can ignore it. Doesn't matter. Now combine like terms. 18y squared and 24y squared. 42y squared. Negative 9y. And then 12 minus 21 is a negative 9. Good? All right. Multiply. This would be a trinomial multiplied by a monomial. X times x cubed is x to the 4th. X times negative x is a negative x squared. And then x times a negative 3 is a negative 3x. It's already in standard form, so you are done. Okay? Here we're multiplying a binomial by a binomial. 6x times 3x. 6 times 3 is 18. X times x is an x squared. 6x times 5, 6 times 5 is 30, right? And then that x that was with the 6. 5 times 3x is 15x. And then 5 times 5 is 25. I can combine the 30x and the 15x. The 30x and the 15x become 45x. So my final answer is 18x squared plus 45x plus 25. Okay. Multiply the polynomials using a special product formula. I don't use a special product formula. I just write it out twice. X plus 3 squared means we're going to take that x plus 3 and we're going to multiply it by itself. X plus 3 squared is the same as x plus 3 times x plus 3. So it's exactly like this one. In process, you just have to write it out first. Okay? X times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. X squared plus 6x plus 9. 6z squared minus 12z, we're factoring out the greatest common factor. I like to do it by writing the greatest common factor below it and doing the division. So 6 and 12, you can factor out a 6. Z squared and z, you can factor out a z. So that means I have 6z being factored out. 6z squared divided by 6z is just z. And then negative 12z divided by 6 is a negative 2. So I have 6z times the quantity z minus 2. Factor the polynomial completely, or say it's prime. So here, because the term in front of the x is a 1, we can go straight to a binomial. What we want are two factors here that multiply to equal a positive 77 and that add to equal 18. This will never be in focus enough for me. All right, factors of 77. I don't know, 11? 7. Do 7 and 11 add to 18? Yay! So I'm going to say it is a positive 7 and a positive 11. X plus 7, x plus 11. You can also write it as x plus 11 times x plus 7, does not matter, okay? Factoring by grouping, on the other hand, we have 4 terms now, 6x squared and 8x and 15x and 20. Good. And just like up here, we want to factor out a common factor. There's nothing that you can factor out of all 4, so I cover up the last two. 6x squared and 8x. I can divide out a 2. 6 divided by 2 is 3. 8 divided by 2 is 4. X squared, I can divide out an x, and x I can divide out an x. So the common factor of 6x squared and 8x is 2x. Then when I go back and I divide 6x squared by 2x, I get 3x. When I divide 8x divided by 2x, I get a positive 4. Do the same with the other half, okay? Now I have 15x and 20. Because this is a plus sign, this is going to be a positive number I'm factoring out, so I can even put a plus right here. 15 and 20, I can factor out a 5. And then there's only an x for the 15, there's no x for the 20, so I can't factor out any variables. So it's going to be 2x times 3x plus 4 plus 5 times 15x divided by 5 is 3x. And then 20 divided by 5 is 4. I have the same binomial that I can now factor out. So it's 3x plus 4 multiplied by 2x plus 5. Factored by grouping. 7z squared plus 16z plus 9, we want to factor this polynomial. The difference now is that the 7 is not a 1, right? Up here we had 1x squared, here we have 7z squared. So this, we can't just go straight to 2 binomials. We have to actually factor by grouping. I might get an extra little bit of paper because this is getting busy looking. So I'm just going to copy 7x squared, z. 7z squared plus 16z plus 9. I want to find 2 factor pairs that multiply to equal 7 times 9 and that add to equal 16. What is 7 times 9? 63. So what will multiply to add to equal 63? This is not how I've been doing this. This is not how I've taught it. Multiply to equal 63, add to equal 16. Well, 7 and 9, right? That works. All right, so now 7z squared and 9 remain, but I'm going to change that 16z to 7z and 9z. Good. Factoring by grouping. 7z squared and 7z, I can factor out a 7z. This is 7z. 7z squared divided by 7z just leaves me with z. And positive 7z divided by 7z just leaves me with 1. Now, 9z and 9, I can factor out a 9. So plus 9, z plus 1. So my factor pairs, my binomials, are z plus 1, that was factored out, times 7z plus 9. Good? Okay, that was number 12. Number 13 asks us to factor, sorry, you can't see it. 13 asks us to factor the difference of two squares. So the difference of two squares, the formula you want to remember is a squared plus b squared equals a plus b times a minus b. You figure out what a is, you figure out what b is, and you plug them in. Or if you don't remember the difference of two squares formula, that's okay. You can also just treat it like a regular trinomial, even though there is no middle term, right? There's no b. 4x squared plus nothing, nothing b, and then your c is 81. It would just be a really big number. Yeah, you could do that. 4 times 81 is 324. So we want it to multiply to equal negative 324, and we want it to add to equal 0. Good? So if you're going to add it to equal 0, think about that. I want it to multiply to equal negative 4, and I want it to add to equal 0. So if I take a negative and a positive of the same number, it will multiply to equal the negative, but it will add to equal 0. So you want to take the square root of 324, it's 18. So you have a negative 18 and a positive 18. They add to equal 0, but they multiply to equal negative 324. So then you have 4x squared minus 18x plus 18x minus 81. Good? What can I divide out of 4x squared minus 18x? I can divide out a 2x, right? So here I have a 2x. 4x squared divided by 2x is going to leave me with a 2x. Negative 18x divided by 2x is going to leave me with a negative 9. Here I have a positive 18x divided by minus 81. I can divide them both by 9. So that's a plus 9. 18x divided by 9 is a 2x. Negative 81 divided by 9 is a negative 9. Good? So then I'm left with 2x minus 9 times 2x plus 9. So it is possible to do it without this formula, but if you are comfortable with this formula, you could use it, okay? A squared plus b squared equals a plus b times a minus b. So a is going to be the square root of 4x squared, right? Because a is equal to the square root of a squared, and a squared is our first term. Our first term is 4x squared. So the square root of 4x squared is 2x. So our a is 2x. B is the square root of b squared, and b squared is 81, right? The square root of 81 is 9. So a is 2x, b is 9, and we just replace those. So that becomes 2x plus 9, or a plus b, times 2x minus 9, a minus b. We got the same answer as we got when we did it the way you can do any trinomial. It was just we had big numbers for them. All right, speaking of intimidating, when you get to your division, you can do it without synthetic division. Don't be afraid if you have a big... When we're dividing this by this, you might get a really big answer with a really big remainder, and that's okay. That does not mean it's wrong. Don't doubt yourself, okay? So x to the fifth minus 8x to the third plus 2x is going to be divided by x plus 4. So long division, you can do this. X to the fifth. I'm not going to write minus x to the 8x to the third. I'm going to write plus x to the fourth because I want to hold space for each descending exponent. So x to the fifth, x to the fourth, oops, plus negative 8x to the third, plus 0x squared. So that term is a 0, but it's still there, plus 2x plus 0 as our constant. Okay, don't forget that your constant is 0, divided by x plus 4. That's the old way to do it. You can do it that way, or you can do it with synthetic division. So in synthetic division, you're going to take the opposite of plus 4, which is negative 4. Next to that, you're going to put a 1 for that x to the fifth. Oh my goodness. This is not x to the fourth, it's 0x to the fourth. Did you guys already catch that? 0, negative 8, 0, 2, don't forget that last 0, okay? So we have 1, 0, negative 8, 0, 2, 0. Let me make sure. 5, 4, 3, 2, 1, 0. Yes, okay, I like it. That just comes down, 1. Multiply that by negative 4, you get a negative 4. Add it to 0, you remain negative 4. Negative 4 times negative 4 is a positive 16. Negative 8 plus 16 is a positive 8. 8 times negative 4 negative 32. Plus 0 keeps our negative 32. Negative 32 times a negative 4. 128. 128 plus 2 is 130. 130 times negative 4. Don't be scared. You didn't do anything wrong. Negative 520. Negative 520 and 0 leaves us with a negative 520. Okay? We started with x to the fifth. That means our answer is going to start with x to the fourth. We have 1 x to the fourth minus 4 x to the third plus 8 x squared minus 32 x plus 130, and then this is your remainder. Remainder, negative 520. Okay, if you get a number that big, you did not do it wrong. That's the only synthetic division on there. Okay, reduce the given rational expression to lowest terms. Y squared minus 36. This is again the difference of two squares. A is going to be the square root of a squared. And in this case, a squared is y squared, so that's going to be the square root of y squared, which is y. B is going to be the square root of b squared, which is the square root of 36, which is 6. Okay? So y squared minus 36 becomes y plus 6 times y minus 6. That's at the top. On the bottom, be very careful. Look at your number first to make sure you can't divide anything out, okay? 15y squared, or sorry, 3y squared, negative 15y, and negative 18. I can't factor out any y's. They don't all have y's, but they all can be divided by 3, right? So I'm going to put a 3 on the outside, and I'm going to factor out a 3 before I try to turn it into two binomials, right? Because usually when I see a trinomial, I want to turn it into two binomials. But before we even turn it into two binomials, make sure you can't make it a simpler trinomial. Good? Okay, so now it's 3y squared divided by 3 is going to give me y squared. Negative 15y divided by 3 is going to give me a negative 5y. And negative 18 divided by 3 is going to give me a negative 6. Yes, be confident. Good? Okay. Not done yet. This one, the top stays the same. On the bottom, we now have, don't forget the 3, y squared minus 5y minus 6. Because the a in front of the y squared is now a 1, we can just call that y. We're going to lead each binomial with y, and then we're going to say what numbers go here. What numbers can you multiply to equal negative 6 and add to equal negative 5? Probably negative 6 times a positive 1, right? So 3 times y minus 6, y plus 1. See where I got that? So I was just doing factoring. I know I didn't leave much room or explanation, but it is the review. We've done it a few times on the homework already. So I have y plus 6 times quantity y minus 6 on top, 3 times quantity y minus 6 times quantity y plus 1 on the bottom. I can cancel these out because they're on both the top and the bottom. So my final answer is, do not forget the 3, y plus 6 divided by 3 times y plus 1. Okay. Here we have two trinomials. We're going to turn them both into binomials. So first one, we want to multiply to equal 16, add to equal 8 to find our two factors. What multiplies to equal 16 but adds to equal 8? I would say it's 4 and 4, right? Yeah. So that's going to be x plus 4 squared, or x plus 4 times x plus 4. I'm going to write it out just in case I can factor one of the pairs out. Good. Next term is x squared plus 10x plus 24. So we want to multiply to equal 24, but add to equal 10. I'm also thinking if I can factor out something by 4, if I can factor out an x plus 4, that'd be good, right? Like I factored out that y minus 6, so I might take 24 and divide it by 4. 24 divided by 4 is 6. 6 plus 4 is 10. 6 and 4 add up to equal 10. So we're going to say 6 and 4 are the factors of 24 that add to 10. So this is going to be x squared plus 10x plus 24 is going to become x plus 6 times x plus 4. Then we will be able to simplify that too. This marker is over. X plus 4 divided by x plus 6. Good. All right. Here, I know we haven't done a ton of this type of problem, but it's an opportunity to apply skills you know to solving a problem, okay? So here we have directions that say leave the answer in factored form. So before I multiply 2x times 14x plus 7, I'm going to look at it just like we looked at 3y squared minus 15y minus 18 and say, can I factor this any further? So I'm going to say it's 2x, but it's being multiplied by not 14x plus 7, multiplied by 7 times 2x plus 1. So I changed 14x plus 7 to 7 times 2x plus 1. I can divide it by 7. So that's why 7's on the outside. 14x divided by 7 becomes 2x. 7 divided by 7 becomes 1. Okay? 4x plus 2, I can also take that and divide both 4x and 2 by 2. 4x divided by 2 is 2x. 2 divided by 2 is 1 times 2. Okay? Because I did that first, I can see now that I have 2 times x times 7 times 2x plus 1 divided by 2 times 2 times 2x plus 1, and I can immediately start crossing things out. This 2 and this 2 can cancel. This 2x plus 1 and this 2x plus 1 can cancel, and I am left with, on the top I just have a 7 and an x, don't forget the x, and on the bottom I have a 2. Good? All right, 18. Simplify this expression. The square root of 18 x to the 7th, y to the 8th. You are welcome to say that that is 18, and then it has 7 x's. Right? And then it has 8 y's. You have a pair of x's, they can come out. Another way to do this is just divide that 7 by 2 and you get 3, right? So those 6 x's become 3, remainder 1. 7 divided by 2 is 3, remainder 1. The y's, same thing. 8 divided by 2 is going to be 4, so we're going to have 4 y's. And then 18, I want to think about perfect squares. I have 4, and I have 9, and I have 16. Which one can I divide by 18 by? I can divide 18 by 9, so it's now the square root of 9 times 2, because 9 times 2 is 18. I have 3 x's I've pulled out, and there's 1 still under there. And then I have 4 y's I've pulled out. I know I messed up the colors there. These 3 x's I pulled out, these 4 y's I pulled out, 18 becomes 9 times 2. The square root of 9 is 3, so it's actually 3 x to the 3rd, y to the 4th. What's left under here are the 2 and the x. Good? Okay, yours will not be quite as complex as that. It's a lot to keep organized. You can do it slower, more one step at a time, less scattered than me. But just make sure you feel comfortable simplifying radicals. And then adding them as well. So here we have 6 square root 12 plus 5 square root 75. I would always start with the smaller of the square roots, 12. Can I divide 12 by any perfect squares? 12 I can divide by 4, right? So that remains 6 square root 4 times 3, correct? The square root of 4 is 2, so that becomes 6 times 2 square root 3, because square root of 4 is 2. 6 times 2 is 12. So that's now 12 square root of 3. That's definitely as simple as I can get it. 3 is not going to be divisible by anything. Now, take 75, because what I want is another term that has a square root of 3. So I'm going to take 75, and if I divide it by 3, hopefully I get a perfect square as my answer, and I do. So that's now 5 square root 25 times 3. The square root of 25 is 5. So just like we pulled out the 2, we are now pulling out the 5, leave the square root of 3. 5 times 5 is 25. Square root of 3. So now we're just adding 12 square root of 3 plus 25 square root of 3. 37 square root of 3. Okay. Now for 20, they're asking us to simplify the expression, the square root of x plus 12 squared. Remember, when you have the whole term squared, you need to write it twice because it's being multiplied by itself. It's not just square this and square this. You need to FOIL it. So the square root of x times the square root of x becomes x, or the square root of x times x, and then it comes out as x, right? And then we have plus 12 square root of x, and then here we have plus 12 square root of x, and then 12 times 12 is 144. Good, so that's the FOIL. Square root of x times x just becomes x. 12 square root of x and 12 square root of x become 24 square root of x, and then 144. You are done. That is as simple as it can become. Good. All right, number 21, we have 3/4 x minus 1 equals 7/8 x. And I know I put 2 of these on here. I'm struggling to remember why, but it's good practice. Just so you feel super comfortable, I guess. 3/4 x minus 1, I'm going to spread it out, equals 7/8 x. You can either find a common denominator, or you can just say, I need to multiply this by 4. I'm going to multiply all of them by 4 times 4 times 4 times 4, and then go through, that'll be gone, and then multiply it by 8, okay? There's nothing wrong with doing it step by step. I want to get rid of these fractions. 4 and 8, I can divide them. They can both, they're both factors of 8, right? So if I multiply this by 8, I'll get rid of the fraction. If I multiply this by 8, I'll get rid of the fraction. So my common factor here is 8, but it's okay if you want to start with 4. In that case, I would start with the biggest, but you'll get the answer if you multiply everything by 4, and then after that, multiply everything by 8. So now we're taking 3. 3 was divided by 4, but now 3 is being multiplied by 8 and divided by 4. 3 times 8 is 24, divided by 4 is 6, right? Which is the same as 8 divided by 4 is 2. 2 times 3 is 6. Negative 1 times 8 is a negative 8. 7 is being multiplied by 8 and then divided by 8, so those cancel, equals 7x. Good? All right, I'm going to move the 6 over because I don't like negative variables. I would rather have a negative constant than a negative variable. 7x minus 6x is just x. X is equal to negative 8. Let's do another one. This one says 7 halves x plus 2 equals 1/2 plus 1/2 x. Good. Now, here we had a 4 and an 8. Now we just have a 2. So I know that all I need to do is multiply everything by 2. Gosh. I try to spread it out and I'm not good at spreading out. Just have a bunch of space right here. All right, 7's being multiplied by 2 and then divided by 2. It's just left with 7. 2 is being multiplied by 2, we get a 4. 1 is being multiplied by 2 and then divided by 2, so it's just a 1. 1 is being multiplied by 2 and then divided by 2, so it's just a 1x. Good? Subtract because I want my variable to be positive. So now that's a 6x plus 4 equals 1. Subtract 4, subtract 4. 6x equals -3. Oh, maybe that's why I added it, so that you'll see that if you get an answer that's a fraction, don't be scared. Divide by 6, divide by 6. X equals -3/6, sixths. But you can simplify this because you can divide 3 by 3 and 6 by 3, and you get 3 divided by 3 is a -1. Sorry, -3 divided by -3 is a -1. 6 divided by 3 is a 2. So your actual answer is -1/2. That's why I put 2 examples. It's okay if you get a fraction. It's not okay if you don't put it in simplest form. All right, 23 asks us to solve the equation 4 times the quantity 5 plus 2x equals 7 times the quantity x minus 1. 4 times 5 plus 2x equals 7 times x minus 1. 4 times 5 is 20. 4 times 2 is 8x. 7 times x is 7x. 7 times -1 is a -7. Now just combine like terms across the equal sign. So I'm going to subtract the 7x, so I get a positive x. 8 minus 7 is x. I'm going to subtract 20. Looks like a z. X is -27. 24, it looks scary, but it's not, okay? 24 says 7, I'm going to leave myself space, divided by 4x minus 5 is 2 divided by x minus 1. How do I find x? Okay? Don't think right now I need a common denominator, okay? A common denominator you need when you are adding or subtracting. Right here, we are not adding or subtracting. We're not even multiplying. All of this is on one side of the equal sign and all of this is on the other. What I want more than multiplication, more than a fraction, more than multiplication of fractions, more than adding fractions, what I want is for these denominators to go away, okay? So I'm gonna take my whole equation. Doesn't matter which side we start with. I guess we start with the left, but I'm drawn to start with the right, but I'll start with the left. 7 divided by 4x minus 5. I don't want this to be a fraction. It's in the bottom, or 7 is being divided by 4x minus 5. So I'm going to multiply 7 by 4x minus 5 so that I can cancel it. If I do it to this side, I have to do it to the other side. Okay, it's only on the top. I didn't draw a line and then do the same thing to the bottom, right? Because then I would just have 4x minus 5 squared on the bottom, and that doesn't help me. So I'm just trying to get rid of this. I get rid of this. It's being divided by that. So I'm multiplying it by that so I can just cancel it. Now all I have on this side is 7. Perfect, I got rid of my fraction. Okay? Over here, I have to call this 2 times the quantity 4x minus 5 divided by x minus 1. Good? You can simplify that if you want. You can, what's the word? Let me think. Distribute. You can distribute the 2 or not. It doesn't matter, okay? Let's do it. 7 is 8x minus 5, minus 10. The whole reason I'm rewriting it is to distribute over x minus 1. So it looks a little bit nicer. You don't have to do that though. What we want to do next is just like what we did over here. We got rid of the bottom of the fraction by multiplying by that denominator, okay? Take all of this. I don't want it to be a fraction, so I'm going to multiply it by x minus 1. That will cancel it just like it canceled this up here, but I have to do it to the other side. So it's now 7 times x minus 1. 7 times x minus 1 is equal to either 2 times 4x minus 5 or 8x minus 10. Because now that canceled that. Now I'm going to distribute the 7x to the x minus 1. 7x minus 7 equals 8x minus 10. Good. I want my, we're back to the step we were on in the question before. I want my x's to be positive, so I'm going to subtract 7x, subtract 7x. Negative 7 equals x minus 10. Negative 10, I'm going to move it. I think that's just x equals 3, right? That was 24. All right, 25, 26, 27, 28. We're almost done. 25. We have I bet we could do it right here. We have ax minus b equals c. They want to find x in terms of a, b, and c. Okay? Get x alone. It doesn't matter that these aren't numbers and they're letters. X is being multiplied by a, and then we're subtracting b from it. Let's add the b. Add the b. Now I have ax equals c plus b. X is being multiplied by a, divided by a. We are done. X is c plus b over a. Good. All right, 26 asks us to use the distance formula. You're welcome to bring the distance formula to the exam with you. Remember, it is the square root of one of your x's minus the other x squared plus one of your y's minus the other y squared. And I think I got those in the wrong order, right? But it doesn't matter. You're finding the distance between them, the difference between them. So it doesn't really matter which one you put first and which one you put second. Just don't confuse them. So I'm going to say my x1 is negative 1. My y1 is 4. My x2 is 2. And my y2 is 6. So that's negative 1 minus 2 squared plus 4 minus 6 squared. Negative 1 minus 2 is a negative 3 squared. 4 minus 6 is a negative 2 squared. 9 plus 4 square root of 13. And you can also look and say, does it look like I'm moving 3 spaces to the left? 1, 2, 3 between this line and this line? Yes. Does it look like I'm moving 2 spaces up between this line and this line? Yes, it does. So that works. Square root of 13 is my final answer. Again, I did 2 distance formulas because I want you to remember that you need to simplify if possible. Okay, this one is more of the math you'll be doing, but you're gonna have to simplify. So that's why I have 26 and 27. They're both the distance formula, but this one reminds you that you might need to simplify. So points P1 and P2. P1, I'll just say that this one's P1. And this one's P2. So P1 looks like it is negative 5, positive 3. Oh, you can't even see it, sorry. Hopefully you're looking at it on your paper. P2 is at 0, 0. Oh, that's excellent. The distance is gonna be x2 minus x1, I'll write it correctly this time, squared, plus y2 minus y1 squared. X1 will be negative 5, y1 will be 3, x2 will be 0, and y2 will also be 0. So we have the square root of 0 minus negative 5 squared plus 3, nope, sorry, 0 minus 3 squared. So we have the square root of 5 squared plus negative 3 squared, which is the square root of 25 and 9, right? So that's going to be 34. Does it look like I went up 5 and over, or up 3 and over 5? It does. Good. Square root of 34. Make sure you cannot divide 34 by 4, by 9, by 16, or by 25. Okay? Start with your higher number. 34, I'm not going to be able to divide by 25. Divided by 16? No. 34 divided by 9? No. 34 divided by 4? Darn it. All right, well, that didn't work either. It's just the square root of 34, but it is possible on the exam that you might have an answer that would look more like this. Darn. All right, that's the whole point of putting that question on there. The midpoint of the line segment joining P1 and P2. So x1 is negative 3, y1 is 4, x2 is 8, y2 is 0. Yeah? Your midpoint formula for, let's just do the x value of your midpoint is x1 plus x2 divided by 2, which is negative 3 plus 8 divided by 2. You need to add the negative 3 and the 8, and you get 5. So it's 5 halves. I would just leave it like that. The y value of your midpoint is your y values added together and divided by 2. So that'll be 4 plus 0 divided by 2. 4 divided by 2, which is 2. And they will want you to write it like this. 5 halves, 2 is your midpoint. Again, you're welcome to put this point into Desmos, put this point into Desmos, and put this point into Desmos, and make sure that this looks like it's right in the middle of these two so that you can feel a bit more confident that you found what looks like the right answer. And that is all for the study guide, but definitely send me an email if you have any last minute questions about the exam. Thanks, guys.